Hi guys, welcome to another video. So today we're gonna be talking about a new model that was released by Google DeepMind. So this new model is the 2 billion version of the Gemma 2 model. And we're gonna be reading a little bit about this paper, which I find to be very interesting because it shows us a new paradigm of training smaller LLMs. So let's get started. So this was released on July 31st. So here we got a blog post on July 31st. Smaller, safer, more transparent, advancing responsible AI with Gemma. So in June, we released Gemma 2, our best-in-class open models in 27 and 99 billion parameters sizes. Since its debut, the 27B model quickly became one of the highest-ranking open models on LSM's chatbot arena leaderboard, even outperforming popular models more than twice its size in real conversations. So here, what they're saying is that this 27 billion parameter model sometimes got close to Llama 70B, okay, which is incredible because it shows that we are getting more progress in smaller models, and this translates to we being able to run these models on less hardware. So they did a new version of the popular 2 billion model, which is Gemma 2 2B. They show here a benchmark which shows this new 2 billion parameter model beating Mistral, even GPT 3.5. This makes me think that GPT 3.5 is really a small model that use distillation, because there was some rumors that this was the case, but Gemma 2 really shows us that distillation seems to be the way to go. And I'm going to be reading more about this in the paper. So here's the model on the Hugging Face website. You can download, okay, there if you want to have. You just have to get access here and add token to your account, which is a process that I want to do right now, so I'm not going to do this. But in theory, you can just do this and be able to use the model. The model is a 5 gigabyte tensor, okay, and you can download that. But now let's take a look at the paper and what the paper says, which are the takeaways that we can take from this paper, which the community and other labs will probably try to replicate and adopt some of the methodologies that they applied here. So let's start. Gemma 2, improving open language models at a practical science. In this work, we introduced Gemma 2, a new addition to the Gemma family of lightweight, state-of-the-art open models, ranging in scale from 2 billion to 27 billion parameters. In this new version, we apply several known technical modifications to the transformer architecture, such as interleaving local global attentions, a group current attention, which are done to optimize the complexity, right? Because this one, it means that they are not doing full attention, they're doing attention just in a group of heads. We also trained the 2 billion and 9 billion models with knowledge distillation, which is pretty much just getting logists from the bigger model and using that to calculate the loss and then update the weights of the smaller models instead of next token prediction. Pretty interesting takeaway from this is that this could lead to a new shift in paradigm where the smaller models are not trained to do next token prediction, but always do knowledge distillation or just the fine tuning that's next token prediction. We are basically compressing the bigger model into a smaller model by doing this. So the resulting models deliver the best performance for their size and even offer competitive alternatives to models they are 2 to 3 times bigger. We release our models to the community. That's pretty good by Google DeepMind. They are now releasing a lot of papers, and it's really interesting because Google now is back on open source, right? That is really interesting. So introduction, large language models, LLMs, have demonstrated strong capabilities in language understanding, generation, and reasoning. Scaling has been the key to this recent progress, with many new capabilities by only emerging at scale. This is the emerging capabilities of LLMs. The newest large models not only reach unprecedented performance on reasoning benchmarks, but they also demonstrate multimodal and multilingual capabilities, which is pretty good, and even the ability to use context lengths over 1 million tokens. This is by the Google team. Small scale models have also shown a rapid increase in performance, but these gains are largely derived from increasing the length of training, which is what we saw with Llama 3 8B. They increased the amount of tokens by a lot. And Llama 2 was 2 billion tokens, and Llama 3 was 15 billion tokens. So that increase in data was the reason why Llama 3 got so much better. This approach only scales logarithmically with the dataset size, and the latest most models require up to 15 trillion tokens to improve the state of the art by less than 1 to 2%. This is by Meta, okay? So we're pretty much reading a diminishing returns when it comes to size of the model. So you cannot have a 1 billion parameter model performing as good as a 70 billion parameter model, even if the data set is much bigger, okay? So there's some things that need to be done, and what this paper shows that there are still some juice that can be squeezed out of these smaller models. Yet these continued improvements provide evidence that small models are still undertrained, which is that we saw, right, with Llama 3 8B. In this work, we explore alternatives to improve small model performance without solely increasing training length. One solution is to improve the quality of the information received by the next network at each training step by replacing the next token prediction task with a richer objective. In particular, we focus our efforts on knowledge distillation, which is a paper by Heaton, which replaces the one hot vector seen at each token with the distribution of potential net tokens computed from larger model. If you guys are interested, in knowledge distillations, you guys can comment down below, and I think I'm gonna do a tutorial showing how to do this for image classification. So this approach is often used to reduce the training time of smaller models by giving them richer gradients. In this work, we instead train for large quantities of tokens with distillation in order to simulate training beyond the number of available tokens. Concretely, you use a large language model as a teacher to train small models, namely 2B and 9B models, on a quantity of tokens that is more than 50 times of the computer optimum quantity predicted by theory, which is by this paper by Hoffman. Along with models trained with distillation, we also release a 27 billion model trained from scratch for this work. We also leverage several known modifications of transformers, namely the interleaving of global and local attention layers from this paper from 2020 and group quantitation mechanism by this paper of 2023. Overall, Gemma 2 significantly advances the state-of-the-art performance relative to comparable scale-open models and even competitive with some models from more than twice their size across a variety of. So it's pretty much the introduction from the paper, and we got pretty much a lot of information just by the opening of the paper. And this goes in a lot of detail. You guys can read the paper if you guys want to read more. They talk about here about local sliding window and global attention. They also talk about post-norm, which is pretty much a way to normalize delays, I think. This reduces the complexity of attention. Okay, let's see. Here they're talking about the training data. So we trained Gemma 2 270 on 13 trillion tokens of primarily English data. The 9B model on 8 trillion tokens and 2B on 2 trillion tokens. So they did not use that many tokens. They pretty much capped 1-to-1 with these ones, but they did do knowledge distillation, which takes information from this bigger model. So with the tokenizer, they are using sentence piece, and they are using a vocabulary of 256,000 tokens. Here is they go one on filtering, infrastructure. They're training on using TPUs, which that is interesting because I think Google is the only company that is using its own chips rather than NVIDIA or AMD or Intel GPUs to train LLMs. So here's the knowledge distillation. Here talking about carbon footprint. Here they go on post-training. Let's go to the benchmarks. If you guys want to read this, you guys can definitely do that. Here we see the numbers on the MLU. So Llama 3 70B 79 and Gemma 2B 75, which is pretty close, given that Llama 70B is more than twice the size of this model, which is a very interesting outcome, given that the 27 billion parameters seems to be targeting GPUs with 24 gigabytes, which are the RTX 3090 and RTX 4090. So it requires huge amounts of VRAM to be able to run. This one you can quantize and give 5 bits, 4 bits, and a 24 gigabytes should be enough to be able to run. I think with 16 you can run with 4 bits, which is still very interesting because quantization does not degrade the model that much compared to parameter size. So let me see here. I would like to see. So here's the new version, and we can see a jump from the first version to the second version here. 10 points. Here it's like more 7, more like almost 10 points, but 6 points, 3 points, 6 points. There is some jump. Yeah, these benchmarks look pretty good. And Mistral, the second version of Gemma 2.2b, gets close to Mistral 7b, which is pretty interesting, some benchmark. Of course, it's still ahead because it has almost 4 times the amount of parameters, but still a nice improvement. And Gemma 7b here, they increase in Gemma 9b, here they're using 71, which is better than Llama 3b. Okay, pretty competitive. So that's pretty much it, guys. Here we just got a bunch of information about safety and what kind of content that they are not able to produce. Okay, pretty much it. Okay, so this is pretty much the model, the paper. If you guys would like me to show you guys knowledge distillation, you guys can comment down below. But now let's test the model, and you guys can download the model. We're gonna be using LM Studio to test this model. I have a tutorial on how to use LM Studio. You guys can check it out. I'm gonna leave a card here. You guys can click and go to that video to do this. Okay, so here we're gonna come here to search, or you can just come here and type LM Studio. And if you search for LM Studio, it's gonna return the models that LM Studio itself quantized for us. We're gonna press enter, and here we can see even the newest models, because here we are sorting by most recent, and we can go down, and here we got Gemma 2 to be instruct UF. It has 4,000 downloads. Let me hide here. You guys can see that I already downloaded this model, which is 2.7 gigabytes. So now we can test this model. I have here 4,000 tokens as context length. GPU offload, I'm gonna load all the layers. Okay, let's load this model. And we're gonna be testing, which I think is gonna be very interesting because we're gonna see the capabilities of this model. Let's start with hello, right? And it was almost instantaneous because this mod is able to produce 34 tokens per second on my GTX 1660 Super, which is pretty interesting. If you have a 3090, I think this model is able to produce like 80, 90 tokens per second, which is absolutely bonkers. Let's say write me hello world in C++. Let's C++. And it did. And here comes a short explanation, and it goes doing that. I would like just to be able to see the explanation, which be very blunt. Be very blunt. Okay. Why it works? Okay. Write me a Python program for text to speech. Text to speech. Let's see what kind of response it's gonna give. So it's using GTTS. Let's say something. Let's say that this requires internet, and I don't want it to require internet. This requires internet. I want something that works offline. Okay. Let me see. So he's pretty much using GTTS. It's giving us an explanation. And let's give this plump. It should recommend TTX. You were right. Relying cloud. Okay. Not ready for offline. Okay. And it gives the answer that I was expecting, which is PyTTX X3, which is works offline. Okay, so pretty good answer, given that I got the answer that I was looking for. But now let's test some other advanced stuff, right? Let's test reasoning. Let's test reasoning in this model. So a test that some people are using, which is bigger, 9.9 or 9.11. So it gives that 9.9 is bigger than 9.11, which is pretty good. This smaller model is able to answer this, which big models are not able to answer. And I'm curious to know why exactly this model is able to do that. I'm gonna go with, I want to know exactly if this is able to answer. Yeah, ChatGPT is able to do so. I think they probably updated the code, right? We've seen so many people talking about this that maybe it's not working anymore. Let's go with which is bigger, 3 quarters or 250 grams of a kilo of a liter of water. Let's see if it's going to be able to answer this. So 3 quarters should be 1 quarter. 1 quarter of a liter, which is the same, right? It's the same. 1 liter, which is okay. Almost got it right? Because the computation here is pretty similar, because 250 milliliters of water is equals to, it should be equal. But it says that a quarter liter of about 250 ml is smaller than it, which is wrong. But let's see what ChatGPT says. which I'm using, I think, ChatGPT O here. Let's see if it's, yeah, both are equal in terms of mass. It wasn't too bad, but we are comparing a model that's running locally with a model that's running on a server. But I think that someday this model will be able to do this. It almost got it right? Let's see. Let's go to the strawberry. Okay, how this is one is very popular right now. How many R's are in strawberries? I'm gonna give double quotes. Let's see. And it got right. It got 3. Let's see what ChatGPT says. 3 R's. Okay. Yeah, it got right. Let's try again. Let's copy and try again. Remember that this is not deterministic. Now it says 2, right? Try again. It got right, 3. So you guys can see that right here, it got it wrong and it was able to correct itself. Okay, so pretty much this is the benchmark that we have for now. Okay, I'm gonna see what other benchmarks we can use to test these models when we got new releases, so we can compare each model against each other. But this is pretty much the video, guys. If you guys like this video, don't forget to hit like button, subscribe, and see you guys in the next one. Peace out.